Hey everyone, welcome back to the REST API in-depth series. In this video, I'd like to go over different types of server-side data storage. We finally have to get through this before we can get to things like the GET request, POST request, and different types of request methods that we've seen before. But server-side data storage is so fundamental to understanding how backends work and REST APIs work that it really deserves its own video. This is probably not going to have a set of exercises, but it's going to set us up really well to actually get into our first request methods in the future videos. We're going to go over things like in-memory storage, key value pair storage, so things like caching that you might do with things like Redis, if you've heard of that, how you might store things in a text file using things like JSON. We'll go over things like a relational database. We won't actually go too deep into it, but I'll just go over the overarching concepts, as well as things like an object database, the kind of prime example being something like MongoDB, and just some other database types as well. But the key really for this video is to get an understanding of what data is and what types of storage different data require and how we'd actually go about thinking about and structuring our application in order to store these different types of data from a long-term perspective. So let's get right into the content. Okay, so to start, I just want to give an overview of this idea of server-side data storage. If you've used data storage on the front end, you might have seen things like local storage in the browser or storing things in cookies, for example. But when we're talking about storing content on the server side, usually we're talking about how do we persist data. And that's a pretty strong and important word to kind of understand. That basically means how do we, if the server even just turns off, like if it totally shuts down, or we have to restart the server, or we lose power, for example, can we ensure that we actually keep that data for our application and for our users so that when it starts up the next time, we actually can persist those that bit of data. So for example, if I register with my email and my password, I want to be able to not have to keep signing up again and again as a new user every time I use an application. I want to be able to sign up one time and then be able to log in the future. Or if I make a post on an app, for example, or I save a photo, I want that to be able to stay there for however long I need it to be, unless I am the one who actually deletes it. So that's what we mean by persistence and data storage. Another important thing to consider when we go through this topic is it's one thing to store data, but it's something totally different to actually search that data. So we need a way to actually efficiently be able to search through different types of content. It might be different to search through things like text content versus image content versus even totally different types of data, which we'll see towards the end of this video. So we have to think about things like this. How do we search for it? How do we structure it? What types of tools and technologies do we need to store this type of data? And lastly, before we kind of get into some of the stuff in the future slides, I just want to mention one thing that usually gets ignored when we're talking about data storage on the server is things like backups. We want these tools in order to be able to kind of meet our idea of persistent data, we want to be able to actually have backups, right? So even if our server is able to shut down and restart with that data on a file on disk somewhere, for example, what happens if that entire computer gets lost, or the hardware breaks down, or the solid state drive or the hard drive stops working for whatever reason? We want a way to actually be able to back up that data, maybe on a different computer or a different system, so that we can actually take care of those kinds of contingencies. So let's take a look at kind of some options that we're going to go through in this video together, and we'll go through some of these examples specifically in a second in code. So these are really the key different types of data storage we're going to be looking at. And I'll mention the ones that we're going to look at in this video, as well as the ones that we're going to be using throughout this series together. But it's really important to actually understand kind of the overall landscape so that you have an idea of what options are there to first place to actually choose from. So the first one we're going to be looking at, and the most obvious one, I say obvious, I don't really like using that word, but the easiest one, I guess, is this idea of in-memory storage. So we're probably pretty used to doing this. If you think of how you'd actually store data in your application, like in a script, for example, you probably create an object, for example, in JavaScript, or a map, and you would like set keys and values in that object and actually store it that way, or you have an array of values and you'll be able to keep it. As long as that program is actually running, you have access to that variable and the content inside of that variable. So that's just generally how in-memory data storage works, at least at a very high level like that. So the issue, however, is if that script has to restart, all of that memory gets wiped out, right, in the JavaScript engine. So we have a fresh set of memory every time we run a new script. So that is only going to work while our application is running. And if we shut it down and restart it, we get a new set of memory. So that doesn't really meet our persistence, but it's pretty good for kind of testing things and getting things working right at the start. Now, to take that concept a little bit further, but keeping with the simplified theme, is this idea of text files. Now, if you think about it, really, this is kind of how we actually store most of our data, sort of, for the most part, on our computer in general, right? We have things like Word documents. We even have image files, for example, on our computer or our phones or tablets. And that's a pretty important way to actually be able to store information. So, for example, we could actually write to a text file and actually create JSON in a text file. Just put that string inside a text file and save it as an actual file. And then we can actually have that continue to be there even if our server starts and restarts and shuts down and things like that. We can have all sorts of text files. We can just have a regular plain text file like a TXT file. We can have CSV files like comma separated value. All sorts of different types of text files are out there, but these are just some examples. We'll probably be using this quite a lot, specifically in combination with the idea of in-memory storage. Now, there's this other idea of key value storage. And if you've used things like local storage in the browser, you probably have seen this before. Another good example of this is a tool called Redis, which we'll look at later. But that's the idea of actually storing stuff in keys and values. And we can actually grab those pretty quickly and their associated values, very similar to an object. However, it's structured in a very strict way, and it's across different languages. One very popular tool as well is a relational database, and this is usually the go-to that most people are going to use, and I'll go into details in that in a second. But this is things like PostgreSQL, MySQL, SQLite, which is probably one of the more fun ones to actually play with locally. And this idea is important when things are related to each other and content's related to each other, and you have a very strict what's called a schema. So we'll get into that later. And then lastly, I want to mention this idea of an object database, which are things like MongoDB, if you've heard of that, or IndexedDB, which is actually available in the browser. And that allows you to store, very similar to how JSON kind of works, objects with keys and values, but in a nice searchable kind of way and a much more robust manner. And it has some guarantees with it, very similar to a relational database. Now, there's many more specialized storage options, which I'll get to later. But I just want to kind of get started with in-memory storage. So let's get started with this. So when I'm talking about in-memory storage, specifically in JavaScript, I'm talking about storing data in things like JavaScript objects or in like a map, for example. Okay, so the pro of this is that it's really fast and easy to set up and use. So as long as you have some like JavaScript code, you can actually just set values in a map or delete values in a map, or you can set values in an object pretty easily. And it's also really easy to access, right? Like you can just refer to that variable. You can either use get if it's a map, or you can just directly index into it using the key name if it's an object. So it's pretty kind of intuitive for us as JavaScript developers. The cons, however, I mentioned before, if the server shuts down, we lose that data because the actual engine has to restart and we lose that memory. And it's really complicated to actually scale this beyond just one script or one application or one server. And I want you to keep this in mind as we're going through these different tools and technologies and ideas, because this idea of scaling something, like imagine if you build your app and it becomes very, very popular, you maybe would have a few hundred users or a few thousand users, or if you're really, really popular, you might have millions of users per day or per second or however long. And simply keeping things like this in this type of matter would become very cumbersome very quickly. Because not only would you probably run out of memory on your server, but you probably would also have a hard time actually searching through all of it, especially if you have to chunk it up into various bits of memory. So let's look at this really quick to start in actual code, just so you have an idea of what's actually happening when I'm talking about memory storage and you have a bit of a mental model for it. And then we'll move on to storing things in text files. So I'll switch over to VS Code over here. I have a little bit of an empty file here. So I'll create a new file over here, and I'll do in memory.ts. So we're going to use Deno here. I'll just zoom in a little bit more here. Actually, I don't think I have to zoom in that much. Maybe this is fine. I'll say function handler. And in here, it takes our request, and this is our request object. And down here, I'm going to say Deno Oops, I forgot to initialize my Deno workspace here. So I'm going to do Command-Shift-P. I'm going to do Deno initialize workspace configuration. I'm going to enable linting, yes, but I'm going to do no for unstable APIs. And that's going to create my nice VS Code settings file over here, the JSON file. Funnily enough, we're going to be using JSON later together. But if I do deno.serve, I can pass it my handler over here, and I'll just use the default port for this, which is 8080, which we'll see in a sec. I think it's 8000. I always forget which default port is with Deno, but we should be able to see it shortly. Now it's giving us an error because we need to return a response here. So in here, I'm just going to return a new response, and in that response, I'll just say hello for now. Okay, so that error goes away. Okay, so what do I mean when I'm talking about in-memory storage? So I want you to think about this. We can either create an object or a map. So if I say like const storage, or I'll just do this. I'll say object storage is equal to an empty object like that, or I can say const map storage is equal to a new map. And in there, we can actually have keys and values. Now, in TypeScript, usually we'd want to define what the types of the keys and values are, but we'll leave that for now so we can be a bit more flexible. Now, how we'd actually store stuff in here is we would actually access this variable directly and put keys or values inside of that object directly. So let's say, for example, that I want to be able to have maybe like a log of the different types of requests that are coming in. So maybe my object storage, for example, might have like a logs key, and that might be an empty array to start, like for example, right? So in here, maybe I would add a log for every request that comes in, right? That might be one thing that we could try. We could do the same thing for a map. We could add the log in there, and I'll show you how that might work in a second. So maybe I'll get the request URL out of here, and I'll put it directly into logs. So what I'll say is I'll say const URL is equal to request.url, and I'll say object storage dot logs dot push, and I'll push the URL onto there. And I could just grab this directly on here, but that's going to add it directly on there. So here we're getting an error with our URL. Argument of type string is not assignable to parameter of type never. That's a very complicated error message. Effectively, what this is saying is TypeScript. So we're actually going to be able to look at interfaces in this case for the first time throughout this series. This is basically saying that this object needs to be typed in TypeScript, since we're using TypeScript and Deno in this case. We could kind of ignore that, but we should probably do the right thing here and use it correctly. So let me show you what is happening right here. We need to tell Deno, and TypeScript specifically in this case, that this logs array is a specific type of array. In this case, we want it to be an array of strings. And it's complaining that it doesn't really know how to deal with this storage array because JavaScript can allow kind of any type in this case. So the easiest way, there's many different ways to do this in TypeScript. However, the easiest way to do this is to use what's called an interface. So let me show you what I mean. I'm going to define an interface, and I'm going to call this interface, let's just call it like logs storage, for example. We'll just add some curly brackets after that. And this is going to define kind of what we want our storage to look like. I don't want to get too deep into this, but I do want to mention this at least once if you're following along in this series, so it makes more sense as to how this works. And you're going to get much more practice with this as we kind of go through this series together. And in this case, I want to say that I want to have a logs key on this object, and I want that to be a string array. Okay, that's how I'd read that. I want there to be something called logs with a value that is a string array. Okay, and you can just kind of semicolon that to end that off. So this is not an object. This is an interface that we're going to tell TypeScript in this case is the type for this object storage in this case. So the way that we tell object storage to use this interface is we put a colon after the name of the variable, and then simply we put the name of that interface that we want to implement. In this case, logs storage. So I'm saying create a variable called object storage, and its type is going to be log storage, and this is the value right here. And notice the value here matches the interface. So we have a logs, which is an array by default. And in this case, we're only going to be able to add strings to it. And if we try to add something that's not a string to it, we're going to get yelled at by TypeScript later on. So let me show you what I mean. If I tried to do like down here, if I did object storage.logs.push and I tried to push like 1, for example, or like, a very large number like this, you'll see we can't add a number to a string array in this case, okay? But notice that our URL here, which is a string, can get added to that log storage. So that's pretty nice. So already some TypeScript help quote unquote, but it is a bit of a setup to do, but it does make things a bit easier in the long run. Okay, so back to what we were talking about. In this case, we have log storage, and we want to be able to add URLs to it one at a time. So in this case, that's exactly what we're doing. What we can also do is we can actually log out that storage. So I do console.log object storage. Now, every time that request comes in, I'll just log it out. Okay, so let's see how this actually works, or I guess what I should probably also do is this URL. Yeah, I guess we can make different URLs in this case, but we'll just go with that to start and see how this works. I was thinking if we could have a better key or something in there, but for now we'll just go with that. I'll open my terminal over here, and I'll do Deno run -- allow -net, and I'll do in memory .ts, just like that. I should probably have the watch, but I'll do that for now, just to make things simple. And I'll copy this URL over here. I'll switch over to my Chrome, create a new tab, and I'll paste that in. And I do get my hello over there quite nicely. So that's the response that we're getting back from the server. And if I switch back over here to my VS Code, we'll see that we actually have 2 printouts here. And the first one has 1 log in it, which is the local host for 8000. And the second one has the second log in there, or the second URL in there, which is asking for the favicon. Okay. And that kind of makes sense because in our browser, we're making 2 requests, one's for the URL, and one's for the favicon to show in the little top of the tab, but we don't have one right now, so it's going to return nothing. If I was to change this URL over here, I'll do maybe /hello at the end, and I type that in, and I switch back to VS Code, we'll see that we have, in this case, my face is covering it, but now we have 3 different URLs in here, right? So we're able to store, well, in this case, I guess we're also adding the favicon again, which is kind of annoying with the way that the browser works, but that's actually exactly what we asked it to do. So we are storing things persistently in this object. So when I requested for hello, I actually made a brand new request to this server. And the old values are still in that storage, which makes sense, right? Because we're storing it in this object storage right here. So as long as this script keeps running, we're going to have access to all the previous values in logs. But take a look at what happens if I stop the server. So if I do Control or Command C, and then I run that command again, and I come back to Chrome and I refresh this page and I switch back, we'll see that now we have it being emptied out with the new values being put in from scratch again. So over here, I went to hello and we're grabbing the favicon as we did previously, but we don't have that URL without the hello there anymore. That was erased when we actually restarted the server, and the array went back to being empty, and now we're just adding to it again. So this is kind of the challenge with in-memory storage, is it gets wiped out, and then we need to make sure that either we persist that data to a text file, for example, or a database, or we're okay with it being wiped out, depending on what the use case is for that actual storage. So I'll just close that over here, and I'll clear that console. All right, and then just to show you how this is done with the map storage, I won't bother typing this for now. We'll actually see a bit of typing for maps a bit later on, since I don't want to spend too much time on TypeScript already. We've spent it with the interface. I'm just going to leave this as a generic type for map. But if you want to see how you do this with map, we kind of would do the same thing. We would say map storage.set, and we would want to set the key of logs to be an array, in this case, of strings. And in this case, we'd want to put in the previous value of the map storage's log value. In this case, it's going to be it would be empty to start. So we'd want to make sure to actually start adding to it over time. So an easy way to do this is actually to do this. We would say map storage.set, and we would set the log value, or I guess we'll keep it consistent. We'll go with what we have here, just so it's the same. we'd say logs, and it's going to be an empty array to start. Just so that we don't have to check to see if it's there to make this a bit easier. Otherwise, we'll have to have an if statement inside of this to actually start setting it. So we're going to say map storage.set logs, and then the value will be map storage. Actually, we'll use array spread here. So I'll say map storage.get logs, and then we'll add to the very end of this. Let me just scroll up a little bit so you can actually see this. I don't get cut off here. Map storage.get logs, and at the very end of here, we will add that URL. So what we're saying here is get all the previous values in logs from a map storage and then add that final URL at the end. There's many ways we could kind of go about this. We could probably spread this up onto different lines, but I'll just keep this nice and concise here just so you can see how that would work with a map. So if I save that and I come back here and I rerun this code, actually what I should probably do here is I'll add one log in here really quick. I'll say map console.log the map storage. And I'll comment out this one here just so that we only see the map to start so you can see how that would work. And if I switch this back on and I come back over here and I refresh this page, what we'll see is our map has the logs value in there, in this case, the hello and the favicon. And for example, if I switch back here and I get rid of the hello and I just press enter there, we will see every single value in there. Like we had before. So this works the exact same way. Again, there's no typing in this case, and we probably want to eventually add that, but you can see how this would work with both a map and an object in memory. Now, the key thing again with map as well is that this is going to get erased once we restart our server. But the key benefit to doing it with things like a map is the interface is a little bit nicer, so we can do set and get, and it's a bit more clear as exactly what's happening. And it's a storage. We just have to be careful with typing it, which we'll see in future videos. So hopefully that one makes sense. I know that was quite a lot to go through in a small bit of code, but you can hopefully see how this in-memory idea works and kind of the benefits and pros and cons to some of that. And we'll compare this to how that works with a file now. So if I switch back here and I switch back to our next storage option, over here, you'll see that this is a text file storage. So this is going to be something we're going to be using primarily throughout this series in combination with in-memory storage. So the idea of text file storage is that we can actually literally store on our disk and create a text file and write to that text file whatever data that we need. So if you think about how this worked right here, we're putting this into a variable inside of JavaScript. In this case, this map right here, or this object storage right over here. But what if we could just take that and put it into a file and actually store that file over here somewhere, like a TXT file or a CSV file or a JSON file. That way, even if I turn this off and I restart it, those values are still in there. Okay, so that's kind of the idea with how we're going to go with this. So we can store it in various formats. The pros for this is that it's really fast, really easy to set up. It's easy to get to the data because we just have to read the file from our disk if we know where the file location is. And even if the computer shuts down or the server shuts down, as long as we're reading that file back in when the computer starts up or when that script starts up, we still have access to that data, assuming it was stored to that file correctly. The only con here, again, is that this doesn't really scale very well beyond one server, because once we have that file on one server, what happens if we have another server or another computer somewhere and we have our script running on two different computers? Then we have to figure out how to synchronize those two text files. It all gets quite complex pretty quickly. So that's where a lot of things like databases, which we'll look at later, do come in and make things a bit easier. But most of the time, we don't really need to worry about that. We can, at least when we're prototyping tools, just work with a single computer and a single file, at least for most projects that we'd be building as a prototype. And then you can kind of deal with that later on. The other issue, though, is that we have to make sure that the format of our data matches what we're doing in our text file. So if it's a JSON file, for example, we are really kind of limited to what JSON allows us to save. So if we want to store things like that cannot be stored in JSON, like functions, for example, then that's not really going to work, right? Why do you want to store functions? I'm not really sure. Most of the times you wouldn't want to, but let's just say that, if, for example, if you did want to store a function, you can't store that in JSON. You'd have to figure out some other format or an image, for example. You can only store the link to the image in a JSON format. You can't actually store the actual image itself inside of a JSON file because it's just a text file at the end of the day. So Let's take a look at how this works in Deno, because it's pretty cool and it's going to help us out quite a lot when we're actually building our apps and going through this series together. So I'll create a brand new file here so we don't get too messed up with what we have over here. I'll close this server down and I'll create another new file over here. I'll call this text file.ts. I'll close this off for a second. I'll do the same thing here. I'll say function handler. This is going to take a request and a request. I'm going to return a response. And here we're going to say deno.serve, and we're going to take our handler over here. And then we're going to use the default port. I think it was 8000 that we saw earlier. So here we'll return a new response just to make sure that it works. I'll just say text files, just so we see something slightly different. And we'll actually deal with returning actual data in the next video. So over here, if you think about it, we need to store data inside the text file. So let's go with that same exact idea that we have over here. So imagine we want to be able to store a list of logs just like this. Okay, how do we do that but with a text file to make sure that when we erase, or so when we restart that server, or our computer shuts down and restarts, or the script even restarts, like we turn it off and on again, how do we actually persist that? How do we keep that data going without actually losing it? So for example, imagine for a second, I create a new file over here. I'll just call this storage.json. I'll make sure it's a JSON file in this case, just so we can actually store JSON in here. And in here, I'll put some JSON data. So I'll say logs like this. And remember that JSON is, everything is as a string. So we can't actually treat it like a JavaScript object. It has to be stringified. So in here, I'm just going to put testing, for example. Okay. What I would probably, I should probably put this in an array, just like that. So this is an array of strings. Okay. Now, what we could probably do is start adding to this logs key inside of this file as if it is similar to this object, or this, I keep switching back and forth by accident, to this interface right here, or this object. So if you think of how we did logs and we pushed onto logs that URL, maybe we can do the same thing with this JSON file right here. It's just, in this case, it's an actual file. We have to make sure we treat it slightly differently using JSON parse and JSON stringify. So let's, first things first, let's grab that URL. So it's like const URL is equal to request.url. Now I want to save that URL to this file. So how do we do this in Deno? So I'm going to say const file is equal to deno.read text file, and we pass it the name of the file. Now in previous videos, we saw things like deno.open, which is much more flexible. However, if we know that we're just dealing with a text file, which we are in this case, a JSON file, it's much easier just to use this shortcut, which is read text file and write text file, because it deals with things like opening and closing all the streams and all the conversions for the different types of data that you could actually write to files. So for example, if we're writing to an image file or some other kind of binary file, we wouldn't be able to use this, and we would have to use the open method for Deno that we saw in previous videos. But since we're actually doing a text file, it's a bit easier to use a shortcut, so we don't have to deal with some of the extra complexities of using things like the text reader and writer and things like that. So in this case, I'll just say I want to open up the file name storage.json, and JSON, make sure you spell it correctly. And then we'll have access to this file object. And you can see that this is, we have to await that. So I should make this an async function. And I'm going to await read text file. And you can see once we have that, we have that file. So if I say console.log, and I'll console log the file in this case, let's see what we actually get if we do this. We should have the content. I should probably rename this to JSON, but let's take a look at what happens if we do this. So I'll open up my terminal here on the right, and I'll say deno run --allow-net --allow-read, and we also need to allow write. So I'll just do that in for now, just so we can see how that's going to work. So we'll do --allow-write, so read and write privileges. And I'm also going to add --watch, just so that I don't have to keep running this every single time. And then I'm going to put the name of my script in this case, which is going to be text file text-file.ts. And I'll run that. You can see the watcher process has started. If I switch back to my Chrome, in this case, I still have the URL loaded. And if I refresh this page, you can see we have text files show up, which is the correct thing. And we can actually see that we do have that string being logged out, which is our file in this case. Okay, so that's pretty nice. So I'll just close that terminal for a second. Now notice that this is a string. I should probably rename this as JSON just so it's a bit easier to kind of reason about what's actually happening, or JSON string, I guess, JSON string, or maybe like, I keep changing my names on these because it's important to get namings right, because you get really confused if you have many lines of code. So I would probably just say like file content. That's kind of what I was kind of going for originally. I'll just say file content, which is a string in this case. So if you hover over it, you'll see that it is a string. And I'll say const JSON is equal to JSON.parse, and we can pass to JSON parse the file content. And now we'll have, instead of just a string, we'll have an actual JavaScript object with that content inside of it. So now if I console.log the JSON as well, and I save that over here, and that's going to restart my server. What I'll see if I come back to Chrome and I refresh the page and I switch back, you'll see that this first one here is the string, and this one here is the actual parsed version in a JavaScript object. Notice that the strings around the key are gone, and then the actual value has been turned into the actual JavaScript value, which is an array of strings in this case. Okay, so just be aware of that. And we're getting two of them because one is for the actual favicon, which we saw previously. Now, I'll just close that for a second, and just so we can deal with this. So we don't need that content now. We've seen how that works. I'll just put some comments here. Read JSON string, and then right over here is we say parse to JSON. Okay, now what would be nice is if we can write back to that JSON and then put it back into the file, right? So for example, if I could take that JSON and add to it, so I can say JSON dot, and in this case, I can actually grab that logs value out of it, dot push, and I can push onto it that URL. Now, this is where things get a little bit tricky. We probably would want to put typing on all this. Just like you saw previously over here, we had to do an interface for this log storage and actually set the interface for this object storage over here. That way we could only push string values in this case without actually pushing the right or wrong type onto it. We would eventually want to do that over here, but I don't want to overcomplicate this example. So we'll just stick with this basic setup to start, and we'll see how we can do that as we go through this series together and actually start building out the APIs. So we're going to push that to that JSON logs value. So this is grabbing, just so you're very clear, we're grabbing .logs, which is this right here. And then we're pushing onto this array, that string. And now what we can do is save back to the file. So I can say Deno dot write text file. And I should probably, I can await this. I don't have to await it, but I probably, it depends if I want to do code after this or not. And in this case, I can Deno dot write text file, and I can write back I should probably do this on a separate line. I'll say const new JSON is equal to JSON.stringify. So this is the opposite of JSON.parse. JSON.parse will take a string and it will turn it into JSON. JSON.stringify will take an object and it will turn it back into a string. So in this case, I want to take that JSON and turn it back into a string. And I want to, this is going to give us a string, the new JSON, and I want to write to that text file the new JSON. Just like that. So in this case, we have to, we got to tell it the name of the file that we want to write to. In this case, we want to write to storage.json. That's why typing sometimes helps. So you can get these types of error messages because I forgot to say the path of the file in this case, and then we pass it the actual string to read in. So that's going to write back to that file after we push this value onto. So add the URL to the logs array, and then turn JSON back into a string. And then here we're going to save string to the file. Okay. So I'll save that, Control S, and I should have my terminal cleared because I have my watcher enabled. And if I come back to Chrome over here, and in this case, I have just a regular localhost 8000. And if I refresh this page, I come back over here, we'll see that those are the values in there right now. And if I open up my storage file, we'll see that I do indeed have my logs and those two values in there. Now, if I come back in here and I go to a different URL, let's do /monkey, for example, and I'll do /monkey. Now, if I come back to here, we'll see, let me just make this a bit easier to see. You can see that our logs has testing in there. It has those two variables in there, as well as our monkey, which is quite nice. So if I switch back to JSON or storage.json over here, we can see maybe if I click save to Control S it so it formats it not all on one line, you can see that we have testing, we have our localhost 8000. These are from the first request that we made, and these are from the second request that we made. So this was already in there when we first loaded up this file. These two got added on that first request, these two got added on that second request. And now if I add a third request, for example, let's just say pandas, and I do that, if I switch back over here and I click on save, we'll see that now we have all those three different URLs being added to that file. Now check this out. If I stop my server and I restart the server, and I make another request. This time, let me just go to let's just do what is another animal? We have dogs. So I'll do dogs. And if I switch back to VS Code, the most important thing to keep in mind here is, let me just reformat this so you can see those previous values, our previous animals, our monkeys, pandas, are still in there, and now we have dogs being added to the end. So all these values persisted even though I restarted that server, right? So even if I close this server right now, and we can see that it's not running at all, there's no more server running at all. If I switch back to Chrome and I refresh the page, I'll get back a site can't be reached. But most importantly, if I open up this storage JSON file, all those values are still in there. So I can either move this to another server for a backup if I want to, or I can load it up into my script, or even pass it to another computer, load it up into its script, and I can do some analysis on it, for example. So this is really, really awesome, right? We finally have a way to persist data with our actual text file storage, in this case, a JSON file, which is really, really awesome. Notice how this is fundamentally different from just storing things in memory here, which gets wiped out as soon as our server has to restart or our computer has to restart. So hopefully that makes some sense. I'll post this code on GitHub so you can take a look at it and kind of look through the comments as well and play around with how it works. Just keep in mind the typing. We'd eventually want to make sure we're pretty good with the typing so that we don't make any mistakes if we edit this in the future. But this is at its core exactly how text file storage would work with something like a JSON file or a text file. Now, if I switch back to my slides here, I just want to show you some other options that you might run into and when they might be important. Oops, I clicked on the wrong thing here. This is zooped off the screen. So let's go with key value storage first. Now, this is very similar to short-term storage solutions like a map or an object. However, the difference is that these can actually persist. And when I say persist, I kind of mean that in like air quotes persist. Now, over here on the left-hand side, I have a picture of a logo for something called Redis, which is a very popular version of this key value storage. It's mainly used as what's called a cache, which we can store values in before or after it hits a database. So we can grab things very quickly from this key value storage, very similar to local storage. However, we can actually choose whether to keep the data or lose the data depending on the type of service that we're using. So this service like Redis, for example, or some others can be set up so that it is persistent or is not persistent depending on what types of problem we're trying to solve. Now, the challenge with this is that this is mainly for simple, short snippets of data, and it's not usually for long-term storage. It's mainly for something like caching. So if I'm repeatedly asking for the same content over and over again, it's probably better to store that in something like this key value storage so I can get access to it very, very quickly, very similar to how we saw with a map, or an object in JavaScript, but there's a little bit more functionality built on top of it, and it can be separated away from our actual JavaScript code, so it's a bit easier to maintain. But the main point is that it still can be chosen as either a long-term storage-ish solution, or mainly you'll see it as a caching or short-term storage solution, depending on what kind of tool you're using. I don't want to spend too much time on this, since we could probably create a whole series on these technologies and how they'll actually be used. And I hope to be able to do this at some point in the future, and especially combining with other cool tools like containerization. But for now, just keep in mind this is one thing that we do have available to us. Now, before I move to the next slide, I do want to mention that the more these tools you start adding together, the more complex the maintenance and the data storage and backup, as well as things like analysis of this data gets, right? If we have multiple places where we're storing data, for example, in a text file, in memory, in this key value storage, in another tool somewhere, if we want to do an analysis on the data, or we need to update certain parts of the app, it gets more and more complex the more these things we're stringing together. So you really want to only be adding these tools when necessary for a specific task that you know is going to solve a specific problem. So that said, I want to go over to probably what you'll mostly see in things like industry or your own applications, which is this idea of a relational database storage. These are tools like PostgreSQL, MySQL, Oracle DB. There's a lot of different relational databases out there, but the idea behind this is that it's a very robust, long-term, highly structured data storage solution. So we want to be able to tell the computer exactly what our data looks like, and that's what's called a schema. So we tell it, as long as the data looks like this, I want you to store it in this particular way. Behind the scenes, it is actually stored in files. However, we don't have to worry about that as developers. We can let the database tool or engine actually deal with that for us behind the scenes, and we can just tell it what to do. So the nice thing about relational database storage is that this does actually work at scale, unlike some of our other tools that we saw previously. We can actually string these things together in things like vertical or horizontal scaling is what they're called, which we'll get into in system design videos in the future. However, there are many different techniques and solutions to make these work at scale. Some are more complicated than others, and eventually this does get to be quite challenging at very, very large scales. However, there are solutions to actually deal with that. The other nice thing about this is that it's very, very robust, which means that we can almost guarantee that we won't lose data. We have many backups of this data, and it's just very consistent, and it's quite standardized and easy to use. The nice thing about this as well is that we can actually search for the data using another language called SQL, which is short for the structured query language. And it's a nice standardized way to actually ask for different types of content and data out of that database, no matter kind of how big or small it is and where it's located. We can do things like give me all the users whose names start with N, or give me all the people who've signed in the last hour. We can ask all sorts of very interesting and complex questions, and it will figure out how to do that on its own. We just have to think of the questions to ask and structure it in a particular language to ask it, which is much harder if you think about it if we were to do that ourselves in something like a text file. Now, the cons is that this is a lot more effort to set up and maintain. This is why I didn't want to do it in this particular video. I do want to show you how you would go about this. However, I'll pull up a couple of things really quick on the Deno website. But it's not that bad to set up and maintain, but it is much more than what we just saw with a simple text file or in-memory storage. The other thing is that you do have to create a data schema first. We have to tell the computer exactly how to store this file and the relationship between these files. So for example, maybe the user has a profile, and every single user must have a profile, and they are related in some way. Maybe every single user maybe has to have like a wallet if it's like a financial application, right? And maybe the wallet's balance has to be a certain amount, for example. So these are all things that we can actually build into these tools, and that is itself a whole separate concept and set of techniques and tools that we need to learn. I hope to make a series on that in the future, but just be aware that it is quite rigid, but with that rigidity comes a lot of structure and ease of querying, but it's a bit more set up to begin with. Now, another common A storage technique is something called an object database storage. And this is very similar to the SQL or relational database storage, but this is for unstructured data. So if you remember, I just mentioned that we need a very strict schema. We need to be able to tell it exactly beforehand what type of data is in there, so we can't store it. Object storage is a little bit more relaxed and lenient. Technically, we can have a schema as well. However, it is a little bit easier to actually add data. This is much more similar to JSON, except it actually scales really well. A typical example of this is something like MongoDB. So an object storage, it does work at scale. In fact, it's the easiest type of database to work at scale because we can have it scale much easier than something like a relational database. It is also very robust, and we can have nice amount of backups and be careful about not losing our data. And it also has a nice query language. Now, each database in this case has a separate query language, slightly different from each other because there's no standard yet for these object databases, since they're relatively new compared to something like a relational database that has SQL behind the scenes to back it up. However, most of the time it's not too big a deal to learn those tools, and you can kind of get up and running pretty quickly. However, the setup to actually get these up and going is a little bit easier than the SQL tools like Postgres or relational database tools like Postgres or MySQL. However, it's not that bad. It's definitely more complicated than a text file and in-memory storage. So there is some friction to getting it set up and maintained. So it's just something to be aware of. The other thing is, since that technically you cannot have a schema with these types of database, you can have what's called the schema drift over time. So eventually the end schema that you might have is so different, or the types of data you have in your database is so different from when you set it up in the beginning that things get kind of lost or buggy along the way, and your application maybe might not know what's actually in there or not in there. And even as a human being looking at the code, you might get confused as to what to check for and what not to check for, because it's changed so much over time. There's no strict standard for what's actually in there and what has to be in there, what's not in there. So just things to be aware of. I hope to make another series again on this in the future so we can actually see some examples of this. But to start, we're actually in this course just looking at the core of REST using text files and memory databases, in-memory database. So the other thing I just want to mention to wrap up this video is that there are many other storage tools out there. I just went over a couple, even though it seems like quite a lot. There are things like graph databases, which are really popular, which allow us to relate content together. For example, if you think of a social network, we can structure things in the database and store that data in such a way that they can relate to each other in a very visual kind of format that we would do ourselves, like on a whiteboard, for example. There's column-based databases. There's these things called vector databases, which is used a lot in the AI communities these days, or machine learning. There's just so many different types of storage tools out there. The main thing to keep in mind is that you always are going to have some type of problem that you want to solve. And there's always going to be some type of data storage solution for that particular type of problem. And you want to be making sure that you're using the correct storage solution for that problem. You can deal with things like scale usually a little bit later, but you do want to make sure that there are solutions and that you are thinking of things architecturally at a higher level so that you don't, for example, only rely on in-memory database, and then as soon as your server turns off, you lose all the user's data. You wouldn't want that to happen. Or you wouldn't want to use, for example, an object database, but then also make sure that it's very strict and the schema is there so that you can not make a mistake with the schema drift over time. So there's a lot of considerations to make, and this just comes with experience and practice. But I do want to show these all to you just so you have some awareness of what's happening, and specifically these tools that we looked at where we saw the text file, the JSON file, and then the in-memory version of the database, or I say database, but in-memory version of the storage in this case with something like either an object or a map. We're going to primarily be using this throughout this series together. So that is going to be a lot of fun, and we're going to even be able to be persisting data through the text files. So before I wrap up this video, I do want to show a couple of tools that you can look at. So if you look at Deno on Google and you type SQLite, SQLite, you're going to be able to look at Deno has a bunch of different tools to use. You can look at SQLite or SQLite 3. I'll just pull up this first one over here. You can see that they have some documentation on how you'd actually search an SQL database. You can see, for example, this is an example of a query language that you would use. So you say create a table, and you want to search for specific types of data, or you insert specific types of data into that database. And you can ask like, who are all the people in this database, for example, and give me their name. So it's a much more strict than what we just saw with our version of our text file or our object file. However, not too different, right? If you think about it, this is kind of similar to our TypeScript version. It's saying like it has to be an integer, this has to be a text. So there is some similarities, but there are also some differences. I also want to show you, for example, MongoDB and Deno. If I pull that up, I think there's a driver over here. So I think you can look at MongoDB's website. I'll just pull up the Deno library to start, just so you can take a look at that. This first one over here, or maybe I'll even pull up this link over here. Hopefully that loads. I'm not sure why this one's taking so long to load. Come on, Deno. If I switch over here, eventually, hopefully that will load, or this one loaded really quick. Let me pull that up. So if I scroll down here, you can see that you'd want to connect to your database. So this is kind of that setup that I mentioned before. There's a lot of setup you have to do to actually get the server running. It's a totally separate server. You can see that you have to pass it some credentials. You can optionally add a schema if you want. You can insert values. You can find values. You can see that finding values is definitely a little bit kind of easier than the SQL one that we just saw earlier. You can just do something like find one or find. You can pass it values a little bit easier, similar to how you would in JavaScript. But it is still a bunch of setup behind the scenes to actually get this working, and you still have to kind of know the API to actually get these tools working. Now, there's just some examples of some of these tools that I mentioned, but there are many, many others, and you can take a look at some of these online if you're interested as well. So I don't want this run too long, so we're not going to have exercises for this video because I want to jump to the actual content for the GET requests and the PUT requests and things like that, where we'll actually start using these data storage tools. So that's where we'll actually get some practice and hands-on, so that it makes a lot more sense as to how these actually work behind the scenes once we actually play around with it. So that's what's going to come up in the next video, which is we're going to look at GET requests, which is our first type of request, finally, out of all the different CRUD operations that we're going to be doing with our REST API. And we're going to be able to actually use these techniques to actually store and process data for different types of requests and different types of responses. So I hope you enjoyed this video. If you did like this video, I'd really appreciate it if you could like the video and subscribe to the channel. I'd love to hear in the comments what you think below. Have you used any of these tools before? Are there any that you like more than others? Have you had any issues setting any of these up? Or are some easier than others? Or have you used any of these in production, maybe with an actual application? If you like this content as well, I'd love it if you could support the channel either on Patreon or on YouTube memberships or super thanks. I would be very grateful for that. But until the next video where we actually get to the GET requests, I'll see you in that one.